Okay, reforming. So I think our friend is asking where this hydrogen is coming from, right? Okay, so this is catalytic reformer. So the main objective is to improve octane number, RON. I think most of us is very interested, right, in RON. What is RON? And then it also involves chemical reaction. So meaning it also have catalyst. And it also producing hydrogen. This is also one of the hydrogen supplier within the refinery punya operation lah. Okay. How does this unit improve the RON, the octane number? So when I mention octane number, it's basically aromatics compound. Okay. Point to options, pens. Okay. So catalytic reforming ni dia it's not heavy, so it's more like a mid punya stream lah. So this is light punya component, this is mid component, this is heavy stuff. So just imagine we have N naphthenes. If you remember, we have Pona, right? Pona. So this is N naphthenes, naphthene rings, or I think for those fresh grads, you might familiar with the term cyclohexanes, right? Cyclohexanes. So the naphthenes in the feed will be converted into aromatics and hydrogen. Okay. Kalau macam nak buang ni. Okay, yang please ignore this line. So this is naphthenes, naphthene rings. So naphthene rings with the presence of catalyst and also the right temperature, it will be converted into an aromatic compound. This is aromatic compound plus hydrogen. This is how we get hydrogen from catalytic reformer unit, right? Interesting stuff, right? So reformate, normally we call it a RON booster. It's also part of the blending component for gasoline. We have other RON booster called MTBE, but MTBE is in the chemical punya part lah. It's not refinery. So we have so this is basically naphtha. I think if you guys remember, Sir Fazrul mentioned about butane, IC5, right? These are the general blending components for gasoline. And on top of that, we have reformate. So reformate, normally the RON is more to 102 or higher. This is RON for reformate. So in the blending side, in the tank farm, so we will inject the reformate to the blending, gasoline blending pools to achieve 95 and 97. Either one. But nowadays, catalytic reformer is no longer an attractive punya unit, because now they are gone to fluid catalytic cracker, FCC. So with FCC, you can have more margin because the feed to FCC is basically heavy stuff. So the heavier the hydrocarbon is, the less valuable. So with fluidized catalytic cracker ni, it can crack the heavy hydrocarbon, the long chain hydrocarbon, to a more valuable product such as naphtha and gasoline. All right. Maybe just some additional information for you guys. Any more question for this slide from audience? Okay. But after this, you can still ask me a question. I mean, from the previous slide as well. So no worries. Okay. So next slide is on cracking unit. So I mentioned about creating a more valuable product, right, from the heavy hydrocarbons. So this is where this unit play their role. We have hydrocracker, we have fluid catalytic cracker. So the main difference between hydrocracker and fluid catalytic cracker is for hydrocracker, it will need a hydrogen. And typically the product will be more focused on diesel, because with hydrogen, it also can saturate the aromatics content in feed. Unlike fluidized catalytic cracker or FCC, so FCC, it doesn't require hydrogen. So when it crack the long hydrocarbon change of hydrocarbons, the long hydrocarbon change, it will also create an aromatic compounds and olefins. So that's why with FCC, we can also achieve the desired gasoline punya spec or blending components. Yep. Okay, both units also involve chemical reactions, meaning you will also have a catalyst and a reactor. Okay. And any questions from the audience?
Sir Azim, I just want to relate lah.
Please.
That's true. What we are trying to deliver here, kadang-kadang yang appreciates ni just only for chemical students, chemical engineering students.
Yep.
Process. But the reality check, sebenarnya this is the basic fundamental yang semua kena tahu.
Yeah.
Even jangan kata mechanical. Non-technical pun dia kena tahu at least for the process flow. Kan macam okay, from supply chain, let's say from offshore crude oil pergi storage tank, pergi ke crude distillation unit, lepas tu convert to di bla 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 kan. Then to me this is not just for chemical engineering as well. Boleh tapi dia sesuai untuk semua, especially engineering punya ni lah, punya course lah. Tapi apa significance tu? Kenapa nak kena tahu? Why we should know this? Kan? In reality punya job punya, kita punya apa tu nama? The reality check yang we are facing now. Macam contoh kalau ada isu, so every discipline nak kena ada, kan? So dia pun kena faham proses tu. Macam mana Azim? Can you explain to us the significance to other discipline as well?
Significance, well, for starter, I mean, engineering, okay, we're talking about refinery lah. Need to be more specific. So in refinery, of course, as a process engineer, so you have to understand the process operations in details, definitely. But then for other engineering punya discipline, such as we have mechanical engineering, rotating, electricals, instrument, and also civil, right? For process, I think at least you need to have some basic idea on what the refineries are and what are the operatings and what are the products, because with that information definitely will help you in your day-to-day job. For instance, for rotary engineer, rotary engineer is basically the engineer who are looking after pumps and compressor. Mechanicals engineer will be more focusing on static equipment like fire heater, uh, column, reactors. Okay, for instance, for rotating engineer, uh, they are responsible for the compressor pumps, right? And definitely you need to understand what type of fluid that are going through your pumps, right? Because you need to have the minimum, density across the pump, so you won't have what we call it, cavitations later on. So by understanding this, basic principle of refineries, it definitely will help you, especially those who are not yet in uh, oil and gas business. I think it's the best start for you to at least understand the basic principle of refineries operations, because later on, let's say if you are fortunate, so you will be undergoing an interview sessions with the operating companies such as Petronas, Shell, or Heng Yuan, or ExxonMobil, for example. Definitely they will ask this kind of questions, right? For gases, we have compressors. So where do we need the compressor? So we have hydrogen here, and we have the light gases. So for hydrogen, definitely you will deal with a lot of compressors. So what type of compressors that you have? You have centrifugal compressors. You have what I call it, reciprocating compressor. And why there are two why are there two type of compressors in the market right now? Why don't we just use one? So basically, maybe I can just touch a bit on compressors, right? So why we need centrifugal, when we need centrifugal compressor, when we need reciprocating compressors. Uh, for the unit that require higher flow rate, higher gas flow, you definitely need a centrifugal type compressor. So I mentioned about light units like naphtha, mid unit naphtha or diesel unit, right? So for naphtha unit, so typically the hydrogen amount required is less. So you can go with uh, centrifugal, of course, because it's less. Maybe it's cheaper. I'm not sure. But then, if you go to hydrotreating at a heavy part like diesel, so the amount of gases will be a lot more, and at the same time, it will operate at higher system pressure, right? So you might have two type of compressor in this unit. So you will have recycle gas, you will have a centrifugal type to make sure that the flow of the gas is at the highest at all time. And also at the same time, you need to provide a very high pressure to the unit. So then you need a reciprocating type of compressor. So these are the things that may help you in understanding the unit. So that's what I'm trying to do lah.
Okay.